Good morning, dear students. Welcome to this session on pre-stressed concrete. We are talking about high-strength steel, so out of which the strength of pre-stressing steel have been talked in the last session. I'll just run through the slides that we have been talked about the last session. So we have defined strength of pre-stressing steel and testing mechanism, and then tensile strength of different forms of steels available, right? This is what we have discussed in the last session, and also talked about stress strain behavior of untensioned steel, nothing but conventional steel, and also high strength steel, and also discussed about difference between the earlier code and the revised code on the different mechanical properties of pre-stressing steel, right? In this session, we'll talk about permissible stresses in the pre-stressing steel, okay? Right. So as per clause 19.5.1, just open your IS codes, look at that clause 19.5.1. What it says is, at the time of initial tensioning, maximum tensile stress FPI initial immediately behind the anchorages shall not exceed 76% of the ultimate tensile strength of the wire or bar or strand, whatever it is. So earlier code it was 80%. Now it is revised to 76%. Okay. So this is the clause 19.5.1, which controls the allowable stress. I mean, how much stress you permit in a pre-stressing steel wire or strand or bar. Okay. So at the time of pre-stressing, initial tensioning period, immediately behind the anchorages, the stress in the steel shall not exceed 76% of its ultimate tensile strength. And last session we have talked about all these values for a wire of so and so form. What is the ultimate tensile strength? So out of that value, you take 76%. For example, if it is 1760 megapascal is the limit, beyond which you cannot tension the pre-stressing wire, right? And there is no upper limit for stress at transfer, means after short-term losses, or for the effective pre-stress after long-term losses. Okay, so no upper limit. Okay, so the limit is only kept on 70. Initial pre-stress only, because anyhow the value is going to be less than this ultimately, because you are going to have losses. Okay, so there is no upper limit kept on the stress in steel at transfer, right? So stress strain curves for pre-stressing steel behavior is once again recalled, that it is initially linear, and beyond 70% of the ultimate strength, behavior becomes non-linear and inelastic, and anyhow there is no yield point for pre-stressing steel. Okay, so unlike mild steel, we have yield point, but whereas for HOSD bars and all, we don't have yield point. So what happens when the yield point is not available? So yield point is defined in terms of proof stress. So IS code recommends the yield point will happen at 0.2% proof stress. Okay, that means the stress corresponds to a strain of 0.002. So take the stress strain curve of steel, then draw a uh, tangent to the initial tangent, draw a line parallel to the initial tangent at 0.002 strain, and it will strike the curve. Take that point as proof stress. That is what is called 0.2% proof stress. Okay, right. This is the stress strain curve given for pre-stressing steel in the IS code, figure 5, famously known as figure 5, which is in class 23.1.1. So see, open your codes, class 23.1.1 F will talk about this stress strain diagram. Now you see on x-axis, strain is drawn in terms of percentage, and on x-axis stresses are plotted as a fraction of ultimate stress Fp. So you see that 0.2% line is this one, and that is meeting the curve here, and that is nothing but 0.9 times, I mean 90% of the ultimate stress, right? Ultimate tensile strength of the pre-stressing steel. Okay, so that is the noted point in this diagram, and this is for all wires. I mean strands and bars, the same curve holds good. Okay, so that is a change in the earlier codes, and this one, different stress strain diagrams were being proposed for different forms of steels in the earlier codes, whereas a single stress strain diagram is represented for the pre-stressing steel in the latest revision of the code. Okay. Anyhow, it says that you obtain the stress strain curve for pre-stressing steel from the manufacturer, and every information from the manufacturer, ultimate strength, relaxation value, and everything, right? That you have to go again for taking the sampling criteria and all that. Okay, so that is already there, a clause on that. Now, stress strain curves for pre-stressing steel are influenced by the treatment process that is given in this diagram. How the treatment process will change the stress strain curve. So the variation of proof stress, 0.2% proof stress for wires under different treatment process are being drawn here. Okay, the topmost curve is for the process of low relaxation, and the middle one, which is a green one, is stress relieved wire, and the bottom one is as drawn wire. And you can see proof stress is the high for low relaxation steel, and it is lesser value for stress relieved, and the lowest for as drawn wires. Okay, so proof stress is low for as drawn wires, high for low relaxation steel. Okay, right. And the design stress strain curves are calculated by dividing the stress beyond 80% of the ultimate tensile strength by a material safety factor, just like your concrete. So material safety factor for steel is 1.15, whereas for concrete it is 1.5. Okay, so these values are to be divided by 1.15 to obtain design strength. Okay, So that is the meaning of this point. So the design stress strain curves, you can plot it just by dividing the values by 1.1. And this is just given in this diagram with a characteristic curve and design curve, okay, put together. So imagine this is the stress strain curve, okay, where these values beyond this point, I mean 80% of the ultimate strength, uh, divide these values by 1.15 and you get this line. That is what is called design stress strain curve. Okay, so this is what is the information regarding the permissible stresses in steel. Okay, so the limitation is only on initial pre-stress value, where at the time of initial tensioning, the maximum tensile stress in the wire or bar or strand, whatever it is, should not exceed 76% of its ultimate tensile strength. Okay, for that matter, the ultimate tensile strength values are given here. Even minimum the tensile strength values are mentioned here. Okay, so all these tensile strength values are to be uh, uh, this is say 2010 for 2.5 mm dia cold drawn wire. So when you are using this wire for pre-stressing purpose, so you cannot go for 2010 megapascal. You have to limit this for only 76% of this stress when you are pulling the cold run wires. Okay, so only 76% of this shall be used, not to the fullest. Okay, so that is what does that mean. Okay, and there is no upper limit for the stress at transfer, as you know, once the tensioning is done, and once it is transferred the stress to the concrete, when you cut the wire, pre-stressing steel wire, it is going to have a lot of losses. There are a variety of losses that we will talk about. Because of that, naturally the stress will come down. So once you maintain that 76%, and it is not going to be more than that anyhow in any of the stages. Okay, so that's why there is no limit given even at the transfer or at ultimate after or at service. Okay, and stress strain curves, there are code specifies 0.2% proof stress shall be taken as yield strength, and that shall be divided by 1.15 material factor of safety for getting design stress strain curve. Okay, and figure 5 is to be used according to IS code for the stress strain values. Okay, and also treatment process is going to affect the proof stress, and the highest proof stress can be obtained with the low relaxation treatment process, whereas as drawn wires will have lowest proof stress values. Okay, and remember, material factor of safety shall be 1.15 for steel. Okay, that will give you the design curve. Characteristic curve divided by 1.15 value will give you design curve. Okay, and we'll talk about the relaxation of stress in steel in further sessions.